In the last video, we looked at solving quadratic equations by completing the square. We used the completing the square method when we couldn't factor our quadratic equation or we couldn't square root both sides. An alternative method is to use the quadratic equation. If we have a quadratic in the form ax squared plus bx plus c is equal to 0, then we saw by completing the square the solutions for x were minus b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic equation. We can just use this method instead of completing the square. So if you look at a quadratic equation and think to yourself, I can't factor this, this is an alternative for you. What we're going to do in this video is just work through some basic examples of using the equation and look at some of the advantages and disadvantages of using it. So let's go ahead and start with an equation. So what I want to do is solve the following equation. Let's take now x squared minus 2x minus 8 is equal to 0. This is in the form ax squared plus bx plus c is equal to 0. If we look at this, we can actually factor it. So I could have x plus 2 multiplied by x minus 4 is equal to 0. So we can see from here that x would be equal to minus 2 or x would be equal to 4. We've looked at many similar equations in the previous videos. What we're going to do is use the quadratic equation instead. So the first thing that we need to do is consider the values of a, b and c. One of the main errors that are made now are sign errors. So let's have a look what we've got. A will be equal to 1. That is the coefficient or the number in front of the x squared term. B is going to be minus 2. Many students seem to just put 2. It's minus 2. And c is going to be minus 8. So we have the quadratic equation, and often you'll be given this in an exam paper, and we can say that x will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. All we need to do is plug in the values. So we're going to have x will be equal to minus b, which is minus 2. Then we will have plus or minus the square root of b squared. That's minus 2 squared, which will give us 4. And then we have minus 4 lots of a, which is going to be 1, multiplied now by c, which is going to be minus 8. And we put all of this now over 2 lots of a, which is 2 lots of 1. So at this stage, you can see that this is going to take a bit of working out from here. So we're going to have x will be equal to minus 2, which will be 2, plus or minus the square root of 4. And then we're going to have now minus 4 times 1 times minus 8 will give us plus 32. And that's all going to be over now 2. So we got x will be equal to 2 plus or minus the square root of 36 over 2. In an exam you wouldn't show all these workings, but I'm doing the first one step by step to give you some idea. So x will be equal to 2 plus or minus the square root of 36, which is 6, and that's over 2. So if we do x is equal to 2 plus 6, that gives me 8. 8 over 2 is going to give me 4. If we take x now and we have 2 minus 6, that's going to give me minus 4. Minus 4 over 2 is minus 2. And we can see we've got exactly the same answers. Clearly, we would try and avoid using this method if we could factor it. Now, I still think completing the square on this particular example is a lot easier. So if you saw the last video, we take x and then half the coefficient of the x term, we square the bracket, subtract away this number squared, we've got the minus 8 and that is equal to 0. So we have x minus 1 all squared, adding the 9 to both sides, square root in both sides, x minus 1 is equal to plus or minus the square root of 9, x minus 1 is equal to plus or minus 3, adding now the 1 to both sides, x is equal to 1 plus or minus 3, and we can see that that's a lot quicker. So sometimes completing the square is a lot better, and straight off we would have factored that one anyway. The reason I always choose a nice straightforward one is to give students confidence. One of the advantages of the quadratic equation is that it can make quite messy quadratics easy to deal with. So for example, if we could see that our quadratic didn't factor and the coefficient wasn't 1, then completing the square is a bit of a nightmare. So if we had, for example, now let's take a quadratic equation. Let's say we've got now 3x squared minus 2x minus, and then we'll have 4. Then when I look at that now, I'm thinking to myself, can I factor that? Well, I don't know. Let's set it now equal to 0. Can I factor it? I might be able to factor it. Can I do anything else with it? I don't know. So let's go ahead and complete the square on this one. So when I'm completing the square, I need to ensure now that the coefficient on the x squared term is 1. So I'm going to divide through the equation by 3. So I've got x squared minus 2 over 3x minus 4 over 3. That's equal to 0. We discussed in the last video that we could simply add the 4 to the other side and go ahead and complete the square on the 3x squared minus 2x terms. I'm going to just go here, so we need half this coefficient, so it'll be x minus 1/3 all squared. Then I'll have minus 1/9. So I'm just squaring this term out, and then I'm going to just put this into ninths. That will be minus 12 over 9, and that will be equal to 0. So I've got x minus 1/3 all squared will be equal to, adding this quantity to both sides, 13 over 9. Square rooting both sides, x minus 1/3 is equal to plus or minus the square root of 13 over the square root of 9, which is 3. So we can see that x will be equal to, adding 1/3 to both sides, 1 plus or minus the square root of 13 over 3. And this gives us what we call exact answers. So sometimes we would be expected to give this. Now, an exact answer is left as a surd, or for example, if you have pi in the answer, or e. These are now, we don't go ahead and decimalise them. So 1 plus or minus the square root of 13 over 3. If we choose a quadratic equation, we could have just gone ahead and done this. So we could have said that a was equal to positive 3, b was equal to minus 2 or negative 2, and c was equal to minus 4, and substituted that in. When you come on to some calculator work, using the quadratic equation is really quite quick. So if you have one of these calculators, what we can do now is simply plug this in. So what I'm going to do is set this up. I'm going to simply replicate, and I'll write the quadratic equation here. X will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead now and just plug this in to the calculator. So what I'm going to have in the numerator is minus, and then I just put bubbles in. You certainly don't have to, but if you're practicing and doing lots of these, then it's nice and straightforward to do this. We start with the plus, then we'll have the square root of b squared, so my value of b is going to go in there, minus now 4 times by a times by c. So there's my 4, there's my a, there's my c, and we put all of this over 2a. So all I need to do at this stage is simply plug these values in. So if I do that, we start with now minus b. So all I've got to do is put in my value of b, which I can put like so. I can put in my value of b just here. I can then go ahead and put a and c in here. So a is 3, and then we got c, which is going to be minus 4. And then all we do is put that over 2a. A is going to be 3, and we will get our answer. So 1 plus root 13 over 3, which we can see is one of our answers from completing the square. And then to get the other one, we would just now change this over, and then we will get our 1 minus root 13 over 3. With this though, we can, so for example, if we were asked to give our answer to 3 significant figures or 2 decimal places, we can go ahead and do that. So one solution is negative 0.868 and so on and so forth. And then the other one, now all we do is swap it over, and we can do it like so. And we can put these in. So an advantage of this now is to store it in the calculator. So I can store that in the calculator. And if I want, I can go back in. So let's go back in now, and we can change this over. We can put the plus in, and we can store this in. So Shift Store B. So now if I recall A, in fact I got A and B in, doesn't matter, we could just switch these over. We can use those later. So this is one advantage of using the quadratic equation. Let's go back up into here. Let's put in now the negative answer. So the negative answer is this one right here, and then we will store that one in as B. So there's B, and then we can recall A if we wanted to use this. So it's in the calculator. That's the exact form. That's the decimal answer. So let's have a look at where this could be advantageous. Say we were doing a question in mechanics. One of the constant acceleration equations is S is equal to ut plus 1/2 at squared. S is the displacement, u is the initial velocity, a is acceleration, and t is the time. So let's say that we were given now the displacement in meters was 80.4. Let's just put 80.4 meters. Let's say that the initial velocity was, let's go for 3.1 meters per second, and let's say the acceleration is going to be 4.2 meters per second squared. So what we have here is a quadratic. So we're going to solve a quadratic in t. So if I put these in, what I've got then on the left hand side is 80.4, and that's going to be equal to 3.1 t, and then we're going to have plus 1/2 of a, so that's going to be 2.1 t squared. So plus 2.1 t squared. So rearranging the quadratic into the form at squared plus bt plus c, I'll set this side to 0, we've got 2.1 t squared plus 3.1 t, and then we've got minus 80.4. Quite clearly, completing the square here is going to be a nightmare. So all I'm going to do is go back now and plug these values in. We can see that our a value is going to be positive 2.1. We can see that our b value is going to be 3.1. And we can see that our c value is going to be minus 80.4. So straight through the calculator, all I'll do is sub these in. So if we go back now, and this is one of the advantages of doing it, I can just go ahead and plug these in. So once this is set up, b is 3.1. So 3.1, let's go and put 3.1 in here. So 3.1, and then we've got minus 4 times by a. Well, that's going to be 2.1 times by c, and c is going to be now minus 80.4. So let's put that in, 80.4, and this is all over now 2 lots of a. Well, a is going to be 2.1, so let's put that in, and we can get our answer for the time. Now, when we look at this, this is giving me a negative time. So we would write in our answer at this stage, due to this being time, t cannot be equal to minus, what was it, minus 6.96? 6.96 and so on and so forth. 6.96, dot, 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 dot. So what we do is go ahead and look and find the other solution. All we need to do is flip this over. So let's flip this now for the positive. So if I delete that and put the positive value in, we got 5.49. So to 3 significant figures, let's put this in, we can put 5.49 seconds, and that's given to 3 significant figures. So what this is saying now, the displacement is given to be 80.4 meters, and that will occur at 5.49 seconds. So we can see using the quadratic equation can be quite useful, and if we've got lots of these to do, we can store these answers in the calculator and use them. So for example now, if I just store this one, it's Shift Store A, it's stored in the calculator. So for example, if I wanted to find the speed this particle, or whatever we were looking at, was doing at this time, we can use an equation, v is equal to u plus at. This is telling me that the velocity is the initial velocity plus acceleration times by time. So we can say that v is equal to 3.1 plus now 4.2 multiplied by my answer, which I've got stored in the calculator. So all I'm doing here is using this now for subsequent answers to questions that we might be asked. This is nothing to do with the quadratic equation. I'm just showing how that we can use this as we go. So 3.1 plus now 4.2, and it's stored in here as a. So we end up now with 26.17. So we'll say that that's going to be 26.2, and that's going to be meters per second. So we can see that we can use these values, and I could just keep going back to that now if I wanted to bring it back up and use it for something else. 5.49 is there. Sometimes when you're doing quadratic equations, you will get a math error. Let's go back to our graphs right here. What I'm going to do is look now at a quadratic equation, and I'll just get rid of this one right here, in the form ax squared plus bx plus c. So let's go ahead and just put this on. Let's put that to 3. Let's just put this to 1. Let's make this nice and straightforward. And then I'm going to put this now let's put this at 2. Now if we look at this here, okay, we can see quite clearly there are no real roots to this quadratic equation. So this would be 3x squared plus x plus 2. It's not crossing the x-axis. Therefore, we wouldn't expect any real solutions to this equation. So let's write this out. This one right here, and we'll just move on. This is 3x squared, so 3x squared plus 2x plus 1. I think that's what we had, is it? Let's just check that. Plus x, so it's plus x plus 2. So let's do that. So plus x plus 2. And we'll set this equal to 0. Now when we're setting this equal to 0, this is saying to me, where is this now y equal to 0? The quadratic equation is generally in the form y is equal to ax squared plus bx plus c. So I'm saying, where is it crossing now the x-axis? That is where y is equal to 0. So if we look at this then, our value of a is going to be equal to 3. Our value of b is going to be equal to 1, and our value of c is going to be equal to 2. So if I plug these in right now, what we're going to end up with, let's go back, see if there we go, there's our quadratic equation. So it's still in there. I mean, you don't have to leave it in there. It's entirely up to you. We've got now, let's put it in b. B is 1, so b is going in, minus now 4 times by a, and a is in here. Let's put a in. A is going to be 3. Times by, now what are we going to have in here? That's going to be positive, let's get rid of that, positive 2. You can of course start this again, and to begin with you might want some practice doing that. Let's get out of there, so 3 times by 2, and then now let's go ahead and put this as 3. See, when I hit this, we're going to get a math error. The reason being is that this value under the root is a negative number. So we got 1 minus, and this is going to give me minus 24, which is minus 23. So clearly we're not going to get any solutions to that. And often students forget the positive and negative signs. So just be a little careful with those. What we're going to do in the next video is look at something called the discriminant, and the discriminant is b squared minus 4ac. It's that part under the square root, and that determines the nature of the roots. So whether we have 2 distinct real roots, so for example, as we've seen before, minus 2 and 4, whether we have a repeated root, so when we have a perfect square, x minus 5 all squared as an example, or we have no real roots. Okay, so that's in the next video. What we're just going to do now is look at just solving a few quadratic equations using this particular formula. Okay, so let's choose a couple. Let's go now for 2x squared plus 7x, and we'll set this now. Let's set this equal to 3. Now, at the moment, this is not in the form ax squared plus bx plus c, so we want to just rearrange and put it in that form. So 2x squared, and then we're going to have now plus 7x, and then we'll have minus 3, and that's going to be equal to 0. So we solve a quadratic equation, ax squared plus bx plus c is equal to 0. Now, at this stage, we can go ahead and plug these in. What I'm going to do, though, is just to be a bit silly on this, I'm going to write this now as minus 2x squared minus 7x plus 3. And I'm going to show that we can do this either way. So a is going to be minus 2, b is going to be minus 7, and c is going to be positive 3. So let's put that in. And the reason I'm doing this is to often show that even if we got a negative, we don't really need to rearrange, we can just sub these in. So let's now get the quadratic up. I'll start again. So we're going to have now minus b. So that's going to be minus, and then we'll have minus 7, plus the square root now of minus 7. So let's put this in, minus 7, and we'll square that, and we can do now minus 4 times by, let's get back out of there. Let's get back under there, I should say. There we go, we're back under there. Minus 4 times by a, so minus 2. Multiplied by c, which is going to be 3, and this is all over 2a, which is going to give me now minus 4. I'll put it in as 2 lots of minus 2. Let's just do that. Over time, you'll just plug the values in. The disadvantage of this is if you're doing it on paper and you're doing it in an exam, for example, showing this working is a bit of a hassle. Okay, so let's go ahead and do that. So we've got minus 7 plus a root of 7304, and then if we do the other one, we're going to have minus 7 minus. So that's what we'll end up with. Okay, so that's using it that way. Let's say instead, so if we wanted to give this as an exact answer, this is an exact answer. It's got a third in. If you wanted to give it as decimal answer, there is one of them. And then the other one, if we put the positive in, we end up now with the other decimal answer. So we end up now with these decimal values. So let's just put this in. What we have is minus, let's write it in, minus 7 plus, and then we have the square root. Let's just grab that up. Square root of 73 over 4. And then we have the negative. So let's go ahead now and use this one, okay? So in this case, A would be equal to 2, B would be equal to 7, and C would be equal to minus 3. So if I just now put those in, we can just switch the signs over. So what we're going to have, let's put that there, we're going to have now minus 7. This one isn't going to matter because we square that bracket anyway. Then we're going to have positive 2, and this time now we're going to have negative 3. And hopefully you can see what's going to happen here. And then in the denominator, we're going to have positive 2. And we get exactly the same. And then all we would do is swap that over. So you can see this is another advantage. You can just put the values in as you wish. So we got that one, and then all we would do is swap this over to the plus, and then we'd end up now with that answer. So you can see from here, we're just ending up now with these two different answers. It's showing it slightly differently, but essentially we're coming up with the same thing. So if you wanted to look at these as decimals, we've got negative 3.886, and then if we swapped it over, the other one we're going to have then is the negative 0.38, and it was exactly the same. So that now is using the quadratic equation. It's entirely up to you. As you can see, it has its advantages, it has its disadvantages. Generally check if the quadratic will factor first. If it factors, factor it. If not, you've got the choice of either completing the square or using the quadratic equation. Unless you're told otherwise, it's your choice.